My name is Daniel Bergqvist, and I'm a solutions engineer on the cloud platform team. So this presentation was originally going to be given by someone else, but I'm a stand-in for Matthew. So how many of you are familiar with cloud platform, Google Cloud Platform? Show of hands. Familiar with Firebase? Written something for Firebase? Okay, good. So, in this talk we'll talk mostly about Firebase, but we will also touch on a little bit about the infrastructure behind Firebase, and then we will look at how easy it is to do stuff with Firebase. So, synchronization is fantastic in our multi-device world. So people expect having synchronized data between their different devices. So you watch Netflix on your mobile or on your tablet, and then you have to leave, and then you want to continue on your mobile, and you don't want to start over. You want everything to be synchronized and real time. This is of course something that is quite hard to do, but something that we are together with Firebase working really hard to solve and to make it easy to do. So Firebase is a Google acquisition. Around 3 years ago, we acquired Firebase. So at Google, we spent the last 15 years to build one of the most powerful infrastructures there is today. So we own our own fiber network. We were the first company that isn't an ISP that actually have our own transatlantic and transpacific fiber cables. Everything to do it really fast and efficient to shuffle data between our different data centers around the world. So what we do at Google Cloud Platform is that we take services that we have built for our own purpose, and we expose it to third-party developers. So everything that we have, or almost everything that we have, is actually built to solve an in-house problem. So MapReduce was built internally to solve our big data pipeline problems. We have BigQuery, where we have the internal name is Dremel, which was we needed a quick way of asking SQL queries over data sets that are petabytes big. And we need responses within 20 seconds. So everything we've done in the area of distributed computing and cloud computing, we've been doing in order to solve our own problems. So this is an opportunity for you to piggyback on that work. So the first and most basic of the Google Cloud Platform offering is of course Google Compute Engine. It's raw VMs that abstracts the physical machines, but you can spin up a cluster, you can do whatever you like to do with it, you have control over the network and so forth. This is known as infrastructure as a service. You pay by the minute. We don't have hourly billing, we have minute billing, and moreover we only do pay as you go, so you pay nothing up front. You use it and then you pay for it. So one step above compute engine, we have container engine. I'm sure a lot of you are familiar with Docker, with Kubernetes and so forth. So I think at Google we're really happy that containers really have taken off, because we've been using containers internally for 10 years. we actually start up 2 billion containers per week at Google. And I also think that containers is great because it really helps you with vendor lock-in. This is actually one great way of moving workloads between different cloud providers, but also moving it from the cloud and back to on-premise, or however you want to use it. So, next in the stack, App Engine, our platform as a service offering. This is known as. This is like really simple. We do all the heavy lifting for you. You focus on your code, and we will scale instances for you. We will take care of managing your containers. It's basically containers in the underneath, but you don't see that. So if you take a company like Snapchat, they are running on App Engine. When they were 4 people in the company, they had users sharing 700 million pictures a day. That is like impossible if you have to do DevOps as well. So they can basically scale from 0 to 1 million within seconds. So the elasticity is fantastic in App Engine. So, but if you're a client-side developer, or if you're developing a mobile app or a web app, and you don't want to think about the backend, you really want to focus on giving your users the best experience possible, then we have a service for you, and it's called Firebase. So Firebase is a platform that will let you very rapidly develop mobile and web apps, and you don't have to have a backend. The Firebase database or the Firebase service is the backend. We will look more into this. So, I would say Firebase is very simplistic. So, we will talk about 3 services today. We will talk about the real-time database. We will talk about user authentication, which can be a hassle. If you want to do if you have to do the OAuth dance and so forth, that is really time-consuming and cumbersome. We've taken a lot of complexity away from that. And thirdly, hosting. So where does your app live? That is also taken care of. So Firebase basically lets you focus on what you do best and leave the rest to us. And to be honest, no user really cares how you shard your database, right? That's not what they're interested in. So, the lifeblood of any application is data. So, we'll start by looking at the real-time database. So, this is a fully managed NoSQL database. And the format that you store in the database is JSON. So, it's pretty standard technologies that you will be working with, and probably something, if you are a web developer or a front-end developer today, it's something that you're quite familiar with. So the multi-client world, like everyone expects that it works all the time, that all your data is in sync, although you have a spotty network connection, or if you don't have a network connection at all, they will still take for granted that the app will keep working, although they don't have a internet connection. And they are all on multiple devices today. So that's quite of a hard problem to tackle. So Firebase is really designed for this world. So it uses data synchronization instead of, I mean, more traditional technologies, they will use request response model, where you send a get request to a server and you get a response back, or you push something from a server. Firebase doesn't work like that. It uses synchronization instead. So, and this synchronization takes milliseconds. So the only thing you need to do in order to get started is to drop the SDK into your app and you're good to go. So we have native SDKs for iOS, Android, and web. We also integrate nicely with, I can't see what it is, Ember, Angular, React, and something else. And there's also a REST API. If you, by any chance, would like to do more server-side stuff, then there is a REST-based API, so you can integrate it with like Java, I think that's Ruby, Python, Go, etc., etc. So one of the things that I would like to spend a little bit more time on is to talk about the architecture. So the ability to speak directly to the database or directly to the server, not going through a like an application server where the business logic resides. So this is the traditional three-tier architecture, where you have a device that talks to an application server, and then the application server takes care of the communication with your backend or with your database. What we do in Firebase is that we have the device talking directly to the Firebase. This this allows us to do powerful offline and real-time capabilities, but it also has some other important benefits. So it significantly speeds up time to development. You don't have to write all that boilerplate server code that just shuffles data back and forth between the server and your database. And you don't have to do all the updates and tests. And it also allows you to offload your operational and scaling challenges to us. So you talk directly to the Firebase service, and we will scale the Firebase service for you. It also provides a centralized control of security. So Firebase gives you a declarative security rules that you control, like if you want writing, reading, or validation of your data, and you can do that on a very granular level. This means that your server code doesn't need to be perfect to avoid security holes. You just need to make sure your security rules are correct, and the security rules are stored in one file. So it's very easy to audit that file. Again, sometimes you may want to have a server running, and then we have a REST-based API where you can hook into a server. So we have customers using Firebase almost as a caching layer for some operations. Of course, you shouldn't use it solely for a cache. There is better technologies for that. But if you have some specific operations that needs that kind of use case, then it could be done. So Firebase will synchronize your data in milliseconds, and I think real time is super important because it increases engagement from your users. It enables collaboration and provides information in a timely and contextual manner. And I think that like a lot of applications today have like set the standard for real-time collaboration. So if you look at like Google Docs, for instance, if you collaborate in a Google Doc, it's extremely real-time. So let's look at how hard or easy it is. I mean, it's up to you to decide if it's hard or easy, but let's look at how you do it. So what we're doing here is that we start with creating a reference to our Firebase. and then we save some data to it. Then we set up a listener that will listen for changes and then display those changes. And down there we just update the data. Now we actually overwrite data, but we could have ref.append, for instance, and you will add data instead. So another really neat feature is that when you don't have an internet connection, Firebase will store your data in the phone's memory. And then as soon as you get a signal again, it will sync it back to the Firebase service. So to illustrate how easy it is to turn on or to enable offline persistence, it's basically the same code that we saw before, but we also had to add one statement. And we talked a little bit about the rules themselves. So this is the declarative language that we use to enable you to set different rules for different objects. So like chat is readable to the world, it's writable to the world, but it has to be a string less than 100 characters, for instance. We could also have said that like it's only readable, not writable, or whatever. Next thing that is quite hard to do, apart from real time, is authentication. So that is something that we work quite hard to lower the barrier to implement authentication in a more seamless manner. So email and password, of course. We will look at how the code looks for that. We also have third-party providers, Google, Facebook, Twitter, GitHub, and a few others. And then, of course, you can set up your custom backend. So in this case, like if Facebook or Google chooses to change something in their protocol, you don't have to change anything. We will do that server side. So you will be protected from these kind of things. So this is a simple login form or authentication form for an email and password application where you use email and password as the credentials. If you wanted to enable Facebook login instead, it would look like this. It's pretty straightforward. So no rocket science going on here. And again, looking also at the declarative rules language. Here we can see that we have a user ID that is globally readable, but it's only writable by the person himself. So super simple to update and also to audit these rules. The last piece that I want to look at is the hosting piece. So we host the app for you. We have like, I don't know, a couple of 100,000 apps right now that are hosted on Google infrastructure. It is backed by a global content delivery network. Everything is SSL by default. And of course you can use your own domains. And this is how simple it is. So we have like a command line interface tool for deploying apps. So what you do is that you build your app, you you're in the same directory as your app, and you just say Firebase init, and then you do Firebase deploy, and then boom, you're done. And then of course you have a web interface where you can see all the data, you can track the status of all incoming requests and so forth. So I think Firebase was created 3.5 years ago, and I think Google acquired Firebase like 2.5 years ago. So now we have like 250,000 developers using Firebase to build their apps. There are more than 2 million devices that are sending data through Firebase at any given time. So, we, in a very, very quick presentation, we covered the basics of Firebase. We looked a little bit at the infrastructure, underlying infrastructure that are powering Firebase. We've looked at the different features that Firebase provides: real-time database, user authentication, and hosting. And we also seen that there is actually people using this tool out there. I would encourage you, if you are interested in Firebase, if you haven't done anything with Firebase but you would like to try it, go to cloud.google.com, sign up for an account. You can get credits, like, can't remember, maybe $300 or $500 in order to get started. Please do that, and happy coding. Thanks for listening.